Alright, we're going to look at three different things today. We're going to write sets of numbers in interval notation. We're going to determine if a relation is a function or not. And then we're going to find function values given a function. Those are the three things we're looking at today. And again, we're on page 9. Is anyone in here familiar with interval notation? No. All right, let's look at number 1 on page 9. It says x is greater than 50. Okay, this is not an interval notation right now, but we want to take it and turn it into interval notation. So what numbers does x greater than 50 describe? All numbers greater than 50. Does it include 50? No, it doesn't include 50. So what I want to do is I'm going to go ahead and write it in interval notation, and then we'll backtrack and figure out what I did. In interval notation, it looks like that. What is that symbol on the right? Infinity. Yeah, can somebody explain to me how this interval notation says the same thing that x greater than 50 does?
When x is equal to 50, y is every value greater.
Okay, it's saying that x is every value between these two numbers. That's what interval notation does. It takes a small number, it takes a big number, and it says everything in between is what we're looking for. That's what interval notation does. So you always want the smaller one first, the bigger one second, and everything in between is what you want. So x greater than 50, we're talking about all numbers bigger than 50, so from 50 all the way out, and our biggest number we can talk about would be infinity, even though infinity is not a real number. Okay? Now, when we use interval notation, sometimes we use a parenthesis like we did here, sometimes we use a bracket. Can anybody kind of figure out when we want to use a parenthesis and when we want to use a bracket? When it equals a number, we want to use what? Bracket. When it does not include the number, we want to use a parenthesis. So in this case, since 50 is not included in my set, I'm going to put a parenthesis on 50. Because 50 is not included in my set. If 50 was included in my set, then I would have used a bracket. Bracket means the number is included. Parenthesis means the number is not included. And that's usually the hardest part for you guys to keep straight is when do I use a parenthesis, when do I use a bracket. Okay, bracket means the number is included. Parenthesis means the number is not included. Okay, so for an interval, you need the small number, you need the big number that kind of, what's the word? The two numbers that kind of encase all the numbers the set's talking about. Then decide if it wants a parenthesis or bracket. Now, why is there parenthesis on infinity? It's not a real number. I mean, yeah, it's not a number, so I can't really put a bracket on something that's not really a number. All right, let's look at another. Okay, I have 8 less than or equal to x less than 99. So what set of numbers is this talking about? 8 to 99. Everything between 8 and 99 is 8 included?
Yes.
Is 99 included? No. Okay, so again, remind me in interval notation, how do I want to get started writing something in interval notation? I need the smallest number and the biggest number that encloses my set. So my smallest number is 8. My biggest number is 99. Then I have to decide if each number gets a bracket or if each number gets a parenthesis. What does the 8 get?
Bracket.
Why does it get a bracket?
It's included.
It's included. What does the 99 get? Parenthesis. So this is talking about the set of numbers between 8 and 99. 8 is included, 99 is not. Okay? One more. Okay, Okay, I have x is less than negative 19, or x is greater than 21. So we're really talking about two different sets of numbers here. What two sets of numbers are we talking about here? What two sets are we talking about?
Everything less than negative 19.
Everything less than negative 19, or
Everything greater than 21.
everything greater than 21. So since I'm talking about two sets, what does that tell me when I go to write interval notation? I'm going to have two different interval notations. So let's look at the one over here on the left first. What do I start with when I'm writing something in interval notation? The smallest number. So what's my smallest number in that first set? What is it? Negative infinity. And the biggest number in that first set is? Negative 19. Okay. Infinities always get to parentheses. What's the negative 19 going to get? Parentheses, because negative 19 is not included. All right. On my next set, what's my smallest number? 21. What's my biggest number? Infinity. Okay, what does 21 get? Bracket. And the infinities always get a parenthesis. So that describes my two sets there. Any questions on interval notation? The key is getting the smallest number in the set, getting the biggest number in the set, and then determining if it's parentheses or brackets. That's all there is for interval notation. Any questions on that before we move on to functions? Alright, now functions you guys should be familiar with. You should have done that in Algebra 1, you should have done that in Algebra 2. What can you guys tell me about functions? And it doesn't have to be in math talk. You can just talk to me about functions. What do you guys know about functions?
No repeating x value.
Alright, that's one way you can tell whether or not it's a function, but I really don't like that definition. But that's, yes, you're on the right track. What's another way of saying no repeating x values? What else is happening if I've got an x value that's repeating? What he's saying is, let's say I had x and y, and I had 5 go with 7, I had 4 go with 3, I had 4 go with 2, I had 3 go with 1. So as you notice, he's saying my x value repeated there. But how else can I describe what happened there?
It met at a point.
What? I've got two y values for the same x value. So this is a case where I do not have a function. So there is not a function when an x value has more than one y value. That's the main thing we need to get at. So for something to be a function, every x value has to have only one y value. That's the main thing you need to know about a function. Every x value only has one y value. Now, what's another way I can talk about x values? How else can I describe x values? I want to talk about two different ways to describe what an x value is. What do I usually do with x values? Am I usually given the x values, or am I usually given the y values? What am I usually given? I'm usually given the x value, and the x value helps me find the y value, right? So x values we want to think of as the input, but we also want to think of the x values as our domain. Right? So x values are our input, and they are our domain. Now, what do we associate with y values? Output, and what's the other word that goes along with domain? Range. Okay, so x value is our input in our domain, y values are our output and our range. All right, so look at 17. They give you a table of values there. Is that table of values, does it represent a function or not a function? It represents a function. Why does it represent a function?
One y value for each x value.
There's one y value for every x value. That's what I want. That's what I want you to associate with a function. All right, look at 19. Now they're giving me a relation, and they want me to determine whether or not this relation is a function. So 1 over x equals y. I need to determine if this is a function. What am I going to do to determine, or what do I need to think about to determine whether or not a relation is a function when they give it to me in this form? What's something I can do to figure it out? Plug in what?
Values for the x.
Plug in an x value, and one of two things is going to happen when I plug in an x value. What two things are going to happen? It's going to give me one y value, or it's going to give me multiple y values. So let's just pick 2. If I plug 2 in for x, how many y values am I going to get? I'm just going to get one y value. So that means this right here is a function. Let's look at another one. I've got y squared minus 2x equals 5. Now, I'm interested in, when I plug in an x value, how many y values do I get? So what do you think something would be good to do to this to be able to help me determine that? Get y by itself. Very good. So to get y by itself, what do I want to do? Add 2x. So I get y squared equals 2x plus 5. What else do I want to do? Take the square root of both sides. Is that correct? No. What's missing? Plus or minus. Plus or minus is missing. So now that I've got y by itself, I can plug something in for x and determine if it's a function or not a function. And what is this? Why is it not a function, Pauline? What does that mean? So for every x value I plug in, I'm going to get two y values, one positive and one negative. So that means this is not a function. So if they give me an equation, what am I going to do to determine whether or not it's a function or not? What's the first thing I want to do? Get y by itself if it's not already there. And then I want to think about plugging an x value in and determining, is it going to give me one y value or is it going to give me multiple y values? That's how I'm going to determine if it's a function or not. All right, then we get to 25 and 27. They're giving me a graph, and they want me from the graph to determine whether or not it's a function or not. And you guys should be good at this. What do I do to tell whether or not something's a function or not on a graph? The what test?
Vertical line test.
The vertical line test. And what am I looking for on the vertical line test? Say it again. All right. So I'm looking to see if it's how many times it touches my line. What's going to happen if it is a function? It's only going to touch once, and if it's not a function, it'll touch 2 or more. That's correct. So if I look at 25, is 25 a function or not?
Yes.
Yes. 27 is not a function because those x values on the left have 2 y values. All right. One more problem. Let's look at 33. Okay, on 33, the directions say find each function value. So what are they telling me about g of x if they're telling me to find each function value?
Plug that in for x.
That's what I need to do, but what are they telling me about g of x if they're telling me to find each function value? What?
G of x equals y.
That's not what I'm looking for, but you think of g. How do I know there's only going to be one answer? Because it's a function. That's what I'm looking for. If they're asking me to find function values, that means what they've given me is a function. That's what I'm wanting you to be able to see that they are implying when they tell me that. All right, and as we said, to be able to find g of -2, I'm going to do what with -2?
Plug it in for x.
I'm going to plug it in for x. So we're going to have 3 times -2 cubed, -2 squared, plus -2 minus 4. Any question?
That's simple.
And then we want to simplify that. What am I going to end up with in the numerator? What's -2 to the third power?
Negative.
8 or -8?
Negative 8.
-8. How do I know it's -8?
Because it's negative.
Because it's an odd exponent. So it's -8, and then -8 times 3 is
Negative 24.
-24. In the denominator, -2 squared is
4.
4, and then -2, and then -4. So the 4s are going to cancel each other out, and I'm looking at -24 divided by -2, which means I get
14.
what?
I mean 12.
I get 12. Okay, and as we knew, how many values did I end up with?
1.
I only ended up with 1, like I should have. All right, so let's look at part B. What does it want? G of 5x? On part B, is that what it wants? All right, so what am I going to do on G of 5x? Plug in 5x for x. So it's going to be 3 times 5x cubed over 5x squared plus 5x minus 4. What is 5x cubed? 125. And what's 125 times 3? 375. What's x going to be? X to the third. Very good. On the bottom, 5 squared is 25x squared, and then I have 5x, and then I have minus 4. Is there anything else I can do to that? No, that's all I can do. All right, one more part. They want g of 8 minus 4b. G of 8 minus 4b. What's that going to look like when I plug in? What's the numerator going to be? 3. 8 minus 4b cubed. On the bottom, it's going to be 8 minus 4b squared plus 8 minus 4b and minus 4. Now, what is this thing that I'm plugging in? What's something I can describe 8 minus 4b as? Since it's two things being subtracted. What can I call that thing? What'd you say?
Binomial.
Binomial. When we're doing these function values, anytime you're plugging in a binomial, just plug it in and leave it. I'm happy with you plugging in and leave it. Okay? What were the other two things called that I plugged in? Monomials. Why is this one called a binomial? Because there's two. The other ones were monomials. If they give you a monomial, go ahead and work it out and simplify it. If they give me a binomial or a polynomial, then go ahead and leave it. Okay? Alright, so what three things did we look at? Interval notation, functions and function values. Those are the three things we looked at today. Any questions on those three? All right. I have your little assignment sheet that I was talking to you about. Go over, make sure you know how to fill it out.
Oh my god, they used to give us so many.
All right, so obviously your name goes at the top, and this is the first sheet that you are receiving, so this will be sheet number 1. That way you can keep everything straight. We are, as you fill this out, you will fill out the left column first. After the left column is done, then we will move to the right column. So in the first column, the date today would be the 20th, so we're going to write 8/20/13 in there, and then I'm going to put the assignment on the board for you, and you'll fill that in the assignment spot. Yes. Not bad. All right, we're going to do 10 problems. 2, 6, 8, 18, 20, 22, 26, 28, 32, and 36.